In this video, we solve problem 15.1.061 from the Larson and Edwards Calculus Early Transcendental Functions, textbook 7th edition. We're just asked to find the divergence of this field at this point. So remember how that works. The divergence of f can be thought of as the del operator dotted with the field f. And if your field has 3 components, we've been representing those components in our class with m, n, and p. Basically what this says is you're going to take this operator, which operates a lot like a vector, and you're going to dot it with m, n, and p. Now, typically when I do a dot product, I'm doing this times this plus this times this plus this times this. We multiply component by component and then we add. But this is a little different. Whenever you're working with the del operator, this is operating on whatever's in front of it. So instead of the partial with respect to x times m, which doesn't really make any sense, we're going to operate on m with this partial derivative operator. So what this says is take the partial of m with respect to x and add the partial of n with respect to y and add the partial of p with respect to z. And m, n, and p, those are these guys. That's whatever was in front of your I hat, your j hat, and your k hat respectively. Or in component form, it can be written like this. So we're just taking the partial with respect to x of x times y times z, plus the partial with respect to y of n, which is x z squared, plus the partial of p with respect to z, which is just 3y z squared. Okay, not too bad at all. Now remember, whenever you're taking a partial derivative, you need to treat the other variables as constants and differentiate with respect to that variable only. So I see this x times y times z, but I think to myself, this is a constant times x. The derivative of a constant times x is just the constant. So this is y times z. And here I'm taking the derivative of all of this with respect to y. Well, there are no y's in here. The derivative of a constant with respect to y is 0. So that's 0. And over here, I'm thinking of this as a constant times z squared. So if you've got a constant times a function of z, remember how we take that derivative. You bring the constant down, and then you multiply by the derivative of z squared with respect to z. And by the power rule, that's 2 times z to the 1 less power. Of course, we could simplify that as 6yz. Okay, so our divergence is a function of, looks like y and z, is this. So we end up with 7 times y times z. Now we were asked for the divergence at a particular point. So here, y is equal to 4 and z is equal to 1. So this is 7 times y times z, and you replace y with 4 and z with 1, and we get 28.